Of course, today I'm going to have a review on midterm two practice questions, and of course, if you ask a question about how the midterm two questions is going to be, it will closely match the areas that we actually going to cover in the midterm two practice. I need you to pay attention. I've attached two materials for review. And of course, you all know the exam is this week, Friday. And I need you to pay attention. Now, the number one in the exam, please pay attention. And this is also being recorded. I'm going to share this recording before the end of today. Number one question in the exam will cover probabilistic graphical model. Imagine you have a question that look like this. Please pay attention. Now, look at problem one. You have a smell of sulfur, so it can be caused either by rotting eggs, E, or as a sign of the doom brought by the Mayan, apocalypse, M. And of course, they said the Bayesian network and the corresponding conditional probability table for this situation are shown below. For each part, you should give either a numerical answer or an arithmetic expression in terms of the numbers from the table below. Now, take a look at what you are giving. Please pay attention. I'm actually seeing four variables that we call node that are connected, E, M, X, and B. Now, if you take a look at the E part, they give you that conditional probability table. Okay, the first one, 0.4, is the probability of E. 0.6 is the probability of E complement. Okay, now, if you take a look at, S here, S depend on E, also depend on M. And of course, since S depend on that and that depend on that, then if I want to talk about the probability of S giving E and M, of course, we're giving all this. Please pay attention, which is actually going to be 8. 2 times 2 times 2. And B here only depend on M. Don't forget, if B depend on M, M has 2 states, B has 2 states, that will be 4. That's why you have 4 here. And for M, this is the probability of M. The probability of M is 0.1. The probability of M complement is 0.9. Now, you are giving the network, and at the same time, you're giving the corresponding conditional probability table. And what is the question? Let's take a look at the question. The question is asking you, please pay attention. The question is asking you to find the joint probability of all the events. But if you look at all the events, it's talking about the joint probability of the complement of all events. That's why you see negative E, negative S, negative M, negative B. At times, we have several ways to write the complement. I can write it like that. At times, I can just do this. I can write the probability of E, okay, S having a bar, M having a bar, B having a bar. I can also write it that way. I can also write it this way. I can do probability of E complement, okay, S complement, okay, M complement, then B complement. I can also write it that way. Okay, so all what I indicate is I'm talking about the negation of each event. Now, I need you to pay attention. If you want to write, they ask you to write the probability of the joints. To write the probability of the joints, you're going to look at the network. You're going to start with probability of E, right? That's why you see this guy. Why am I putting minus? Because here they say minus. Then M standing alone. That's why you see this guy. Then the next is probability of S depending on E, depending on M. That's why you see this. And the next is the probability of B depending on M. That's why you see this. Is there anyone in this class who doesn't really understand how I figured this out from the network? Is there anyone in this class who doesn't understand how I figured that out from the network? Whenever they ask you the probability of the joint, you actually going to look at the network. Okay. Now, but you know what? After having that, okay, what are you going to do next? Because they want you to compute. This is just an expression, okay, for the joint probability. Now, if I want to compute, the question is, what is probability of negative E? Oh, you come to the table, 0.6. I plug that in. What is the probability of negative M? I'm going to come to the table, it's 0.9. I plug that in. What is the probability of, please pay attention. Please pay attention. Okay. Now, what is the probability of negative S given negative E, negative M? Okay. Where am I? I'm actually going to come here. Okay. Negative S. Okay. I'm going to come here, negative S, given negative or negative. So I'm actually going to come here. Take a look at this. I'm going. Oh, it's looking like this guy. Can you see this guy? This is the probability of a negative S given negative M, negative E. That will be 0.9. And that's why I put 0.9 here. Then the next one, what is the probability of a negative B given negative M? I'm coming to this table here. Negative B, okay, given negative M, okay, is 0.9. Can you see that? I put 0.9, multiply all of that, I'm done. I'm done. But let me tell you this. If you don't know how to read the network to be able to write the joint probability, okay, you may not be able to know how to plug in the values. And you may not be able to understand how to answer probability query. Now, what if in a situation where I change this, I can change this to be all positive. It can be a combination of negative and positive. The structure is still going to be the same, except what is going to change is maybe you're talking about negative S or negative this and so on like that. Now I want to move to the next question. The next question say, please pay attention. What is the probability that the ocean boy, okay, is either ocean boys or not? That will be plus in the B. Okay, that will be plus in the B. Okay, now if I want to figure out the probability of a B plus, please pay attention. If I want to find the probability of a B plus, okay, now I'm focusing on B because I'm focusing on B plus. That is actually what we call a total probability in Bayesian theory. Now, the total probability, I need you to pay attention. I want to focus on probability of a B plus, but if you go back, B, B depend on what in the network? B depend on what? On M. Please pay attention to the network. B depend on M. I want to figure out the probability of B. And B depend on M. So if I want to find the probability of B, I'm actually going to find the probability of B, comma M plus probability of B complement M, which is what I have here. Please pay attention. Okay, which is what I'm actually having. Take a look at this. If you take a look at this guy now, B plus, given that it depends on M, multiplied by the probability of M, or B plus, given that it depends on negative M, multiplied by the probability of negative M. This is total probability in Bayesian theorem. Now, all what I'm just going to do is to go to the table and just start plugging in the values. The B plus given M, I'm going to come to the table. Okay, I'm actually going to come to the table. Okay, I take a look at this. B plus giving M plus. B plus giving M plus is 1. Can you see that? That's going to be, that's one. That's why you see me putting one here. Then the B plus, the probability of M plus, the probability of M plus, the M plus is 0.1. Can you see M plus 0.1? And that's why I'm plugging in 0.1. Then I'm going to go to the other one and plug in the same. I'm done. This is what we're doing here. We are marginalizing out M. We're marginalizing our M. We're trying to figure out the probability of B plus. Don't forget, B depend on M. If I want to figure out the probability of B plus, I have to consider a situation where I observe M and when I do not observe M. When I do not observe M is M negative, and that's why this is going to be called a total probability. Is there any question on this? Okay, I want to move right now. Just pay attention. What is the probability that the Mayan, apocalypse is occurring given the oceans are boiling? That's a conditional probability. The probability of M plus giving B plus. And of course, from the fundamental theorem of probability, don't forget that if I have a probability of A given B, it is the probability, I can rewrite that as probability of B given A multiplied by probability of A or divide by probability of B. That's from the fundamental probability theorem you've learned before. Okay. And so if I want to find the probability of M plus given B plus, and that would be equal to the probability of B plus. Okay, that would be equal to the probability of B plus given M plus multiplied by probability of M plus divided by the probability of B plus. And all what I just need to do is just to go to the table, the conditional probability table given, then I'm just going to start plugging in. Okay, so what is the probability of B plus given M? I'm going to go back to the table. B plus giving M plus is 1. Can you see that? I'm actually going to read it out. I'm going to plug that in. Okay, that's why you see 1 here. What is the probability of M plus? I'm actually going to go to M plus. Okay, the M plus is 0.1. Okay, I put that. Then lastly, what is the probability of a B plus? Then I'm going to go to the table. Okay, going to the table now. The probability of a B plus. Okay, if you take a look at what I have, I think I found the probability of a B plus in question B. Can you see that? Okay, the probability of a B plus that I found in question B, I'm actually going to plug that in here. So which means for you to be able to provide an accurate answer for question C, of course, you need to be able to get, you need to first get question B correctly. Okay, take a look at that. I'm done. This is a conditional probability. Okay, now the question continue. It's another question. Please pay attention. What is the probability that the Mayan apocalypse is occurring, given that there's a smell of sulfur, the oceans are boiling, and there are rotting eggs? Okay, this is interpretation, the probability of M plus, given all of that. But there's something I needed to see. Please pay attention. This is going to be easy. Okay, why did I say this is going to be easy? Is because if I have, for instance, in the theory of statistics, uh if I have the probability of you know A plus, if you take a look at what I have here, if I have a probability of A given B, C, and D. For instance, if I have a probability of A given B, C, and D, it's going to be the ratio of the joint force. It's going to be the ratio of everything, the ratio of A, B, C, D, divided by the probability of B, C, D. Please pay attention. From the law, if I want to have the probability of A given B, C, D, okay, the probability of A given B, C, D is going to be the ratio of the joint, having all of them in the numerator. That's why you have the probability of A, B, C, D, then divided by the probability of the given. The given is the B, C, D. Can you see now? Okay, and that is why if you take a look at what I have, okay, if you take a look at what I have now, so the B, C, D, The one in the bottom, the one in in the denominator is a total probability. When I say total probability, if I want to find the probability of BCD, okay, I'm actually going to consider A plus when I did not consider A. And that is exactly, please pay attention. If you look at the numerator, this is this. If you take a look at what I have, the probability of the joint, okay, the same way that I did the other time, if I have the probability of A given B, C, D, I can actually switch that. Okay, in the switching, 1 second, I wanted to see this. Now, if you take a look at this, I said the probability of M given all of that, okay, number one is going to be a joint. Can you see the joint? Divided by the probability of this guy. But you know what? The probability of that guy, I'm actually going to have two situations, okay, where I'm going to say the probability of BCD, okay, and when I observe A, plus the probability of BCD when we do not observe A, and that's why you're seeing a sum. And that very sum centered on A, which is going to be, if I want to rewrite that, if I actually want to rewrite that, okay, so if you take a look at what I have here, okay, that is a situation where I'm focusing on M, okay, I'm focusing on M. Another one is when I put negative M. Does that make sense? Which is going to be the other part, okay? So when you plug in the values, of course, when you follow all what we've done, A plus, you go to the table, M plus, all of these are in the table. By the time you plug them in, you're actually going to get your results. Okay, so, and this is a final one. This is just to answer a question whether they are independent or not. Of course, the only way we can tell whether two variable, I think we got a good numbers of way to investigate whether two variable are independent. When the conditional probability, like for instance, if the probability of A given B is the same thing as probability of A, then A and B are independent. Okay, if probability of A given B equal to probability of A, they are independent. So here, I find the probability of A given N, I get a result, and I found the probability of A is 0.4. Since they are the same, then I'm actually going to say they are independent. Okay, they are independent. Otherwise, if it is not the same, I'm actually going to say they are not independent. I want us to pay attention now. I think I also attach, before coming to the factor analysis, I think I also attach, there's another one. Take a look at that. This is another example on probabilistic graphical model. Okay, if you take a look at what I have here, you have a network, okay, given. And let me tell you this. Do you know I can give you a question and I ask you to draw a network? Please pay attention. Let me tell you this. In this exam, I'm only going to set 3 questions. One on probabilistic graphical model, the other one on factor analysis, and the last one will be on MDS. The MDS is going to be multiple choice. I'm going to ask 5 questions under MDS, and it's going to be multiple choice. But there's going to be a lot, the serious question will be under probabilistic graphical model. And let me tell you, on the factor analysis, I'm going to produce an arrow output. You just need to answer the question. You don't need to use arrow. The arrow output will be provided. But right now, I'm still on probabilistic graphical model. Now, I want to give you another option under the probabilistic graphical model. Please pay attention. Do you know I can give you a scenario and ask you to draw the network? This is the scenario that I gave you. Look at the scenario. Please pay attention. Ask me question if you don't understand. Now, you're given this. There's a lot of variables here. Okay. Uh, you know, this corresponds, we have a party, smart, creative, homework, project, success, and happy as variables, and they are connected. Now look at the first one. Okay, I said HW depend only, please pay attention. Okay, I gave you this scenario. Okay, and I said homework depend on party and smart. Like if they give you homework in class to be able to do the homework, it depends on whether you have a reduced party or you are smart. So if I come to the network, you're going to see me, you can see that homework depending on what smart and party. Do you understand that? Okay, I first draw that. Does that make sense? Please pay attention. Focus the board. Focus the board. I want it to succeed. If you don't understand, ask me question. Now I draw that. The next one. Mark depend only on smart and creative. You're gonna draw mark. Okay. Can you see mark? Okay. Mark depend on creative and depend on smart. Can you see now? Okay. You're gonna draw that. Another one said projects depend only on smart and creative. Okay, performing well in project. Look at, oh my God, look at that project depending on the creative and smart. Okay, now another one, success depend only on own work and project. Of course, your success in class depends on whether you are able to, do your own work, and at the same time you complete your project. Okay, so I'm actually gonna write success. Can you see success? Success depending on project, depending on homework. And lastly, okay, being happy depend on party, okay, on MEC and on success. Let's go there. Okay, let's see that. Happy, there's gonna be three arrow. One go to the party, one go to the mark, one go to the success. Let me say this. The probability is one that I'm actually gonna give you stuff that look like this, and I'm gonna ask you to draw a network. The probability is one. If I were you, try it out. And that was why I asked a question here. Look at what I said. I said, draw the Bayesian network. This is a network. They're going to give you the relationship. You're gonna draw the network. Does that make sense? Okay. Now, the next thing now is, oh my God, write the joint distribution as a product of the conditional probability. When I say the joint distribution, I want you to do the probability distribution of the joint occurrence of all the variable. What are you going to do from the network? You know what you're going to do? Oh, you fall first, right? Probability of creativity multiplied by probability of smarts multiplied by probability of parity multiplied by probability of project depending on creativity and smart, multiplied by probability of mark depending on creativity and smart, multiplied by probability of homework depending on smart and party, multiplied by probability of success depending on project and the homework, multiplied by probability of happy depending on mark and the success. Oh my God, that is what I did here. Having you to write the probability of the joint occurrence, okay, the probability of the joint occurrence, which is what I've done here. Can you see that? That's what I've done. Now the question I'll say, what is the number of independent parameters needed for each conditional probability table? Now, if you want to answer what is the number of independent parameters needed for each conditional probability table? Now, they want you to figure out, okay, how many parameters do I need to compute probability of creativity? How many parameters do I need to compute the probability of smart? How many parameters do I need to compute the probability of parity? How many parameters do I need to compute the probability of a project given creative and smart? But let me tell you this, each of these node, each of these variable, they have in two states. It's either somebody is creative or not, somebody is smart or not, somebody attend a party or not, somebody complete a project or not, somebody have a mark or not, somebody complete homework or not, somebody have a success or not, somebody is happy or not. We have two state for each of that. But you know what? Based on the network, this is what I'm actually expecting from you. Please pay attention. Okay, you know, all of this is actually from from here. After looking into the network, and you find the probability distribution of the joints. Okay, now because creativity, smart, and party. Please pay attention. Creativity, creative, smart, and party do not depend on anything. Because of that, don't forget that each of them have two states. The moment I know one state, I know the other. If I know the probability of being creative, I can figure out the probability of not being creative using the complementary law. Okay, so right now, I only need one. I need one. I need one parameter for creative. I need one parameter for smart. I need one parameter for party. But how many do I need? When a project depends on creativity and smart, then I'm actually going to need four. Okay, projects depend on creativity and smart. That is depending on the other two. It's going to be two multiplied by two. I'm actually going to need four. When math depending on creative and smart, I'm also going to need four. Yeah, when the binary variable is conditionally depending on two other binary variable, I only need four. Okay, now four. But take a look at this. Happy depend on three. Success, that and that. How many do I need? That would be eight. Two times two times two. That would be eight. Therefore, the total number of parameter that I need is when you add this guy up. Does that make sense? When you add all of this up, that will actually give you the total parameter that you actually need. Okay, using the network. How many parameter? When you add it together, what is the total? That would be okay. Can somebody confirm that? What is 8 plus 4 plus 4 plus 4? How many 4 do we have? 16. 16 plus 8. 24. That would be 27. Okay. And that was why we have that. The total. And another question has, what is the total number of independent parameters? That's going to be 27. Can you see that? But let me tell you this. Without you using Bayesian network, let's see how many parameters you're going to have. How many variables do we have? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. If I want to know the possible number of parameters without using the network, that would be 2 raised to power 8. Can somebody tell me what is 2 raised to power 8? 2 raised to power 8 is what? 256. That's a lot of parameter. So using Bayesian network, you're only going to use 27. And that is one of the advantages of Bayesian network. And that is why with Bayesian network, we save enough parameter space. Okay. Can I say this? The majority, like I said, I'm going to set 3 questions. Go ahead. Okay. Okay. So if a binary depending on one binary, that would be 2. If one binary depending on 2 binary, that will be 4. If one binary depending on 3 binary, that will be 8. Does that make sense? But if I only have, unconditional situation where I have the probability of A, where I have to state just one parameter. Does that make sense? Okay. Now, let me say this. We have 3 major questions in this exam. But you know what? This question is going to carry a question on probabilistic graphical model is going to has a weight of 40%. Then the one on factor analysis, we have 40%. The one on the MDS is 20. I'm only going to have a multiple choice on the MDS. Okay, you don't need any computation. It's just going to be a theoretical question. Okay, where you're going to choose your. Now, I want to show you now, since that is done, please pay attention. Okay, another question that I'm actually going to say that we're going to have a 40 point is factor analysis. Okay, it's going to be a question on factor analysis. Oh, let me see. That's a factor, sorry, not factor analysis, that's a mistake. Principal component analysis. Okay, now you're not going to, I'm going to generate you an output. Arrow output, you don't need to, you're not going to use arrow. Please pay attention. Are you going to see, can you see this guy? This is the arrow output that arrow output has already provided. Can you see that? Providing this arrow output now, all of this, okay, but there's something I needed to pay attention to. Okay, I computed one based on covariance matrix and the other one based on correlation matrix. Okay, and I'm going to ask you a question. Pay attention to question number one. Question number one said, in general, what property does principal component possess that the original variable does not? This is a theoretical question. Okay, if I were you, spend more time on principal component analysis. Okay, so I said, of course, the principal components are uncorrelated, where the original features are correlated. I'm done. Another question. This is not from the output. This is not from the arrow output. This is just a theoretical question. Now let's go to the second question. Write the equation for the first principal component. Write the equation for the first principal component. Please pay attention. This is also being recorded. I'm going to make sure I publish this recording before the end of today. But pay attention now. Take a look at this. If I want to do that, I'm actually going to go to the output provided, and I will go to the eigenvalues section. Can you see PC1? I'm actually going to write a linear combination between this guy and this guy. Okay, it's going to be this guy, B length minus this guy, that plot. So I'm going to write the linear combination of that. What am I doing? That's for the PC1. And if you go back right now, if you go back to the answer that I provided, okay, can you see that? Can you see the linear? I'm done. You just make use of the outputs. Okay, you know, I know there's a lot of PCs. There's a PC1, there's a PC2, there's a PC3, there's a PC4. But look at what I said. I said, write the equation for the first principal component. What if they say, write it for the second principal or for the third principal? You're actually going to get it from that, from the outputs. Now, let's go to number 3 now. Number 3 said, compute the variance of the first principal component. Compute the variance of the first principal component. I'm actually going to go to the outputs, but I'm going to tell you whether you are going to use the correlation. Now, oh my God, they want you to compute the variance for the first principal component, but take a look at this. Standard deviation of the first principal component is 805.3158. If I want to find the variance, I will square the standard deviation. I'm actually going to square that value. You can see everything is already provided in the arrow output. It is just left to you to just go there to do the needful, okay? So the square of the standard deviation is actually variance. Now, I'm done with that one. I'm done. I'm going to go to the next question, okay? I'm going to go to the next question, okay? I'm already done. You know, I squared that, okay? Or we call it lambda 1. Another question say, okay, now you need to know how to interpret. Interpret the first eigenvector computed from the covariance matrix and discuss how it relates to the covariance matrix. Okay, interpret the first eigenvector computed. Okay, the first eigenvector, okay, I'm actually going to go to the PC1 column and I want to interpret, my interpretation is actually going to base on the feature. Don't forget, the principal component is a linear combination of the feature. I said body mass dominates. How do I know body mass dominates? I'm actually going to go to the output. Okay, I'm going to go to the PC1. Okay, how does he dominate? Okay, oh my God, oh my God, look at this guy here. I'm focusing on this guy. That this guy dominates because it has the highest value. That's the interpretation. So the body mass G dominates the PC1 because I'm looking into the contribution. It has a very huge contribution. So if I were you, why can't you try to understand how to interpret a particular principal component? What if I ask you about PC4? What dominates in PC4 is B depth. Okay, B depth dominates because of the 0.9. Take a look at that. That dominates. That's what I mean. Okay, so your knowledge of the interpretation of the principal component will be tested. Okay, now I'm actually moving. Okay, there are other general questions. Okay, now agenda number 5 said interpret the first eigenvector computed from the correlation matrix. Now, like I said, I provided two outputs, one based on correlation matrix, the other one based on the covariance. Now, let's see where the correlation starts from or the covariance starts from. If you take a look at the first one here, all of this is for covariance. Now, let's say where correlation is going to start from. 1 second. I'm actually going to indicate that. Okay, here. You see that? C-O-R-R. But I'm going to indicate correlation matrix. I'm going to indicate the covariance matrix. Okay, so you know what you need to do without wasting your time? Study all this material. Like I said, the exam is going to involve 3 areas. The first area is probabilistic graphical model. The second area is principal component analysis. In principal component analysis, I'm actually going to give you an arrow output. I'm going to have several questions. Okay, each, for the principal component, 40%, for, the probabilistic graphical model, 40%, the MDS, I'm going to ask just 5 questions on multiple choice. Okay, for MDS. Look at that. You have to understand. Which of the following best describe the purpose of multidimensional scaling? Of course, just a multiple choice. You don't need any explanation. Just there's going to be an option A, B, C, or whatever. Just pick your answer for the MDS. Okay. What type of data is typically required as an input for classical MDS? Of course, it's a distance matrix. Okay. So, an isomap is considered a type of what? That's a non-linear. Okay. And so on like that, when you take a look at, there's possibility under the MDS, you are likely going to see some questions that also relate to sparse PCA and PCA and stuff like that. But let me tell you this. I'm not going to go outside this, all the material, all the practice questions, that I've reviewed. I want to say one more thing before I go. And I need you to pay attention. Okay, I need you to pay attention. Is everybody ready? Now let me tell you this. A philosopher said, and I quote, preparation for adversity is the best way to prosperity. If I want to prosper in whatever I'm doing, I need to be ready for adversity. And what is the adversity? Adversity is like an hurdle, the hurdle that I need to skate through before I'm actually going to record an excellent result. If you focus on these areas, if you spend your time on, the practice review questions, you should be good for this midterm too. I'm going to say one more time, the midterm too, the order that you need to actually handle is number 1, you should be preparing for probabilistic graphical model where I'm actually going to give scenario. I'm actually going to ask you to, to draw a network and answer some probabilistic questions from the network That will give you that will worth 40 points. And number two, I'm actually going to give you an arrow output for principal component analysis. And I'm actually going to have several questions on that. Make sure you revisit your principal component analysis. You are not going to do anything with R. Okay, no R. We're not using R. The arrow output will be provided. And that's going to work for the point. And the last question is going to center on MDS, centered on sparse PCA and PCA, and maybe yeah, maybe luckily, maybe one of question may come from factor analysis, but they're going to be 5 questions, multiple choice. You do not need any explanation on that. We have started strongly. I want us to finish strongly. And if your grade in midterm one is not that strong, okay, this is an opportunity for you to fix that. Okay, just like what I used to tell students around me, anybody around me, prepared for the day of battle. Okay, prepared. There's always going to be a day of battle. One of my 5 girls used to ask me question, why do we have trouble? I said, I don't know, but trouble is going to come. But I don't pray for trouble to come. But 4 of us try as much as possible to avoid trouble. Don't get into trouble. Don't get into confrontation. But when trouble comes, handle it and handle it with, carefully. Okay. Now, the trouble I'm talking about here is your exam because this very exam is actually one of the hurdle that you need to figure out on the way to success. Okay, all what you just need to do is just take your time. Even though situations are difficult, take your time. You're gonna figure it out. Okay, just take your time. You're actually there's gonna be a race against time. One philosopher said, and I quote, "The road to success is very narrow, and everyone in the world want to pass through the narrow way. But going by the accommodating capacity of the road cannot take everybody at a time. But you know what my friend said? Some will go, while some will wait. Who are those that will go? Who are those that will wait? But that question is left to every individual to answer. But you know what? There's something I know. The whole world will step aside for a man or woman who know where he's going. When you know where you are going, the whole world will step aside for you. And the only way to know where you are going in this course to pass excellently is to review the practice questions that I've just walked you through. Once again, number one, focus on probabilistic graphical model. You're actually going to be given relationship. They're going to ask you to draw the network. They're going to ask you to answer some probabilistic questions from that. And number two, they're actually going to be a question on principal component analysis where I'm going to provide you with the arrow output. And of course, based on the arrow output, then you are expected to answer some questions. And lastly, there's going to be question on that centered around MDS, centered around sparse PCA, centered around PCA, centered around factor analysis, but it's just going to be 5 multiple choice questions. You do not need to explain, then you just need to pick the right answer. And make sure, on that very day of exam, you are around like 15 minutes to the time because we actually want to have a race against time. Just going to be 15 minutes. And of course, we only allow scientific calculator, okay, scientific calculator, and we also allow cheat sheets. We allow like the same thing, the same number of pages that was allowed during the midterm one. Believe you can do it. Are you ready? Okay. See you on the day of exam. Bye for now.
Okay. I forgot that the homework was due on Sunday instead of like Tuesday, like normal. But since the solution isn't posted yet, is it
The
possible
solution to what?
the homework? I forgot that it was due on Sunday instead of Tuesday.
Okay.
So,
So when you send it to me and uh the TA,
okay.
and I'm gonna comment that the TA should grade that.
Okay. Thank you.
You're not gonna lose any point.
Okay. Thank you.